Good morning everyone, this is Sachin Singh from Group 87. In this video, I will be explaining more about the project implementation that I have done during the course of the semester in the course DS551. So this video will be in particular divided into three parts. First part, we will be discussing more about the database implementation. Second part, we'll be taking deeper into the code. And third part, I will be discussing further about the user interface. So let's start with the first part. So in the first part, I will show you how the database stores and implements all the partitions, all the metadata and everything in that. So basically for connecting to the database, we use the PyMySQL library and also we used Amazon RDS as you can see in the screen. Its URL is written here, user as admin, password of course my own password, then the database name. Next, I move ahead to show all the kinds of tables currently existing in the database. In the database, as you can see, there is a table called as crime-o underscore partition. Crime-o is basically the data set that I have uploaded it myself. So I uploaded the database data set for around 100 partitions. So what I did was I implemented a function that would divide it into 100 chunks of equal size that would be combined into one particular table for each chunk, and like the first chunk will be labeled as crime o0, second will be crime o1 up to crime o99 because it's gonna be one less than our total size, the index number. And next I also implemented a function to create a partition table that keeps a track of all our partitions in the crime o underscore partition, which has details of all the inode numbers of our partitions. Like I will just show you next. Let's go partitions. Here, as you can see, it's the inode number of every other particular table, the 0th index, first index, second index, up to 99. So this is how I implemented some part of our metadata. Next, also we had to implement a directory structure and file system like implementation. So I will show you the tables which I have particularly used for those implementations. For the sake of those implementations, I created three tables. The first one is directory underscore organizer. Next is files underscore locator. Third is presently working directory. The table directory underscore organization has two attributes which I will just show you right now by using describe directory underscore organizer. Here, as you can see, there are two attributes, the parent underscore directory attribute and the child underscore directory attribute. Both are of varchar 200 size. So in this, what we did is, like if we are in a particular directory that's currently a parent directory for any new created directory, we will input, for example, if we are currently in home and we want to create a directory in that, so we will input into this table the value of home in the parent directory and the name of the child directory that the user wants to create it himself. Next, I will also show you the content of the files underscore locator. Oh, sorry, I think the name was incorrect. Yeah, so it's parent underscore directory and child underscore files. So whenever we create a file through put implementation in our file system, it basically implements as I had shown you partitions, and further it goes one step ahead to input the data of the file, that is the name of the file, into this table as the child underscore file and the current directory name in the parent underscore directory field. So this is how we implemented it. And next I have also implemented presently working directory, since it was kind of becoming hard to keep track of the global variable in our program and it was kind of static. So I implemented a table separately in order to store the presently working directory. So anytime we change our directories, the value of the present working directory, that is the 0th index of this table, would surely get updated throughout that incidence. Like if, for example, it's currently home and we change directory to user, it will gonna become user. So this is how most of our database implementation was done. Next, this is all the code that was used to experiment around with the data and see how it particular will work and will not work. I tried many kinds of functions. In the next part, I will be covering more about the code that has been actually implemented using the Streamlit library and more of the backend code to link with the database. So now we move on to the second part of this video, which shows our implementation for the whole program and the user interface as well. So as you can see, I imported the first few libraries, the Streamlit library, LST, then the Pandas, PyMySQL, Base64 for displaying our image and rendering our UI better, random for generating random numbers that will be to be inputted in the inode numbers, and next it's NumPy. So as you can see, I initially established a connection with my database through this function, which I had shown previously, and then use the cursor to point to it. Also, I noticed that I set it to auto commit equal to true, and it was becoming really big hassle to set it to commit after every single operation. So as you can see, there is a function called as map_p. It is a part of the PMR implementation, although it's task 2, but since I've implemented it first, I will be covering more details about it right now. So map_p takes into input the table name, like it's the partition table name is crime00. It will come into this. The query value, the value for which we're gonna search, and the option is actually the attribute for which we are gonna search, and I is of course the index. So actually I would like to correct myself. It would be the original table name in here and the index that is 0 in here. So basically we combine it into a single string for a search query to our database and then run pdn.read_SQL that extracts data frame value from the database. So outputs return. And next you can see there is a reducer function. Reducer function basically runs the map_p function on all of the partition tables from crime00 to crime99. That's what it does, and then it particularly appends it into a list, and it concatenates it into a single data frame and sends it back to the user. This function is basically for part of rendering our UI's background image, since Streamlit library actually does not have any function basically to render a background, so we had to implement our own function for the same. Now, as you can see, this is the put function. Put takes in the file name, that is crime0, that is the location crime, sorry, and the number of partitions that the user desires, which will be taken as an input from the user. So the input from the user, a bit of a here and around would have been done, since some of the variable names were not compatible with what could be inputted into a SQL database. So here, as you can see, its number of partitions equal to k. Then I set np.random.c2 as I don't want my database to be ever changing. So even the randomness should be fixed to a number. So I did the same. Then after that, I created a partitions permitted indices for partitioning the data set, sorry. And then I took into consideration how it's going to be uploaded. Next, create table for Crimo partitions, and it goes on to create tables for all of the partitions from 0 to 99, and after that it performs insertion, as you can see here, insert into files underscore locator. So it also implements another table. It's a kind of a similar implementation to map and reduce. You can consider it put as the reduce function, and it's running the map function, that is csv underscore to SQL on each and every table starting from crime mode 0 to crime mode 99. Here you can see it performs insertion continuously for every row of the data frame splitted from 0 to 99. Next, we will move on. These are just the implementations that were tried for making the model better, but out of 3 to 4 particular different kinds of implementation, the one which I found is what I explained to you. Next, there is a pwde function which returns the value of presently working directory in the table, which is stored in the pwd table. Next, we move on to the header function, which is used for rendering the font better for some parts of our page. Header 2 for the similar criteria. Next, we move on to these are the other functions as well. The extractor function is used for our cat functions implementation for extracting particular values from, let us say you want values from partition 0 to 4 or 5. So you will input the total size of partitions that you want, and it will extract you the output up till the fifth partition, or it could even be the whole partition. That's totally up to the user, but he has to input the number of partitions that he desires, whether it's the whole number partitions or a few of them. Next, I move on to extractor P. That was another kind of implementation for the same, but extractor O was found to be better in our case. Now, the special reducer and special map were particularly used for a better implementation of the basic version. As you can remember, in the basic version, it could only query for one particular attribute and would output all the attributes to the user. So in this case, I let the user select the type of attributes that he wants to see, and also allows him to select what kind of attributes he wants to be queried upon in the form of an entry from the user. Then this is the start of our user implementations rendering part. Here you can see I've used st.title, st.text, and header functions to implement some parts of the user interface to show text sections. Then here you can see rm function has been implemented to remove all the tables, as well as go on to remove the partition table. Next, I have shown my expander function, which is a part of the cat function, which intends to display all the desired output by the user to the user itself. Actually, sorry, I would correct myself. My expander function is basically for the drop down in the user interface that I would show you in the next part to allow the user to select what kind of part he wants to execute right now, what kind of part he doesn't want to execute from cat, rm, put, to PMR functions for search attributes. Next, as you can see here, it's the mktr attributes implementation, which allows us to make the directories. Here you can see the remove directory part, which allows us to remove a directory in our presently working directory, the child directory in our presently working directory from the metadata itself. Next, I also implemented another function to return the partition value. Like if the user wants only the fourth partition, it will return the user fourth partition itself, no other partition. Next, I've gone ahead with the other parts of implementation. Here comes the PMR function, which first part is the basic PMR function that I've shown you in the start of this video. Next comes the second part, which is a further better implementation of this and allows the user to give in two inputs as per his desires. Now I would like to end this part of the video here itself, and let's move on to the next part of the video, which explains more about the user interface. Welcome to the third part of the video. Now I will take into consideration the user interface. As you can see, the user interface here implemented using the Streamlit libraries. There's a background image. There's a separate section, navigation section, which are used for only the implementation of the put function, which the user is basically expected to start with, as the other functions won't work if it's not implemented and no execution is performed. So we went ahead with the implementation, as the execution requires processing around more than 10,000 rows. So it basically takes around 10 minutes. So I went ahead and implemented it, executed it initially to show the other parts. So here comes the cat function implementation. In the cat function implementation, as I told you, it could output all the partitions, or it could output only the one single up to results up to the fourth partition or the fifth partition. So here I go ahead with this. It would basically take some time, and see, I have got details of the total size. It's 9,900 as well. Next, I ask for the details up to the third partition, which would be executed a little faster. As you can see, it's a 300 is the size of the scene. Now I move ahead to current directory structure, which details our current directory structure directly from our the table, the directory underscore organizer table. Then the presently working directory, as you can see, it's actually home right now. So it will be displaying home. We can change directory by putting into the value. For example, user. It will only work when the user implements actually inputs a value that is a part of the child underscore directory of that presently working directory. Now I go ahead with directory underscore content checker. So I will show you content of home. Home, as you can see, it contains user and Crymo, since I initially implemented it to execute and store Crymo in the home directory itself. Next, I can go ahead and show you the content of the user. It contains another directory called Sachin, that's my name. Now, there's an implementation for mkdir that allows us to input into any directory that we want to create. Let's say I go ahead and create, say, I created my directory under my surname, and now I go ahead and show, and as you can see, as directory has been created here itself. Now we move ahead to the delete directory implementation, where I will attempt to delete my directory that I created right now. And as you can see, it got deleted right now itself. Apparently, the web page cannot refresh continuously, as Streamlit is meant to be executed in a sequential manner. So to refresh this content, it would not be automatically rendered. We can use other user interfaces, but Streamlit library has this limitation. Next, I move ahead to partition checker. I desire the fifth partition to be displayed, so I go ahead with it. And as you can see, the fifth partition of our dataset has been outputted. Let's go ahead and refresh our page for once. Now I implemented this another function, get partitions, to get all of the partition locations. So get partitions, just clicking this will locate all the inode numbers that I'm storing in the database. Next is the PMR function. This is the basic PMR function implementation that I talked about in the start of the previous section of the video, the D underscore number. So let's go ahead and search for 1030. Let us select something from our CAD itself. Let us go ahead and select this value 100112612. Now, as you can see, it's the same output as before. It contains, we can match it right now for ourselves itself. 1216 central, and it was 2, and it was battery pool is simple. So it matches our results. Next, I show you the more complicated implementation that I made for this. So here you can go ahead and select what you want to be displayed, area underscore name, part 1, 2, and what else should we select? Victim underscore description. So here the user is expected to directly given the input and separated by an AND. So of course the values that he has to input are displayed above. So and we can take into account let us take a crime code 1 to let us take the status IC and go ahead with this. It will take some time, but as you can see, it has returned the results and with the number of partitions as well. The partition 0 contains this data about it, the IC part, and the partition 2 is containing this data. And basically, that's all we found for victim underscore age equal to 55 and status equal to incarcerated. And here you can see it has been also combined into one single table itself. Now I go ahead and if we can execute this part of the processing, that's the delete underscore file. Here we just give the input crimo and the total partitions that were given initially, and here we go. It's actually deleted. I can show it to you in the directory display, in the file display itself. Yeah. Oh. Here it's actually this display. It's deleted. So actually the crime partitions and the other files have also been deleted. So that's it for my video for this project. And this is my overall implementation for the same. Thanks to Professor Wensheng Wu for teaching the DS551 course and allowing me the opportunity to explore more on the side of the distributed file system and learn more about user interface using Streamlit, more about how DFS works in particular. So that's it for me. Thanks a lot. Have a good one.